Yeah. All right. So first, the project content. So what we are going to do, basic SQL operations on university database. I posted 2 databases for this textbook. University, the first one, company, the second one. The company one, we mainly use to do our practice assignments. So university, we will use it for our project. When I post the project, I can attach that database under this project for your convenience. Yeah. Description. All right. So mainly we practice basic SQL operations in a web project. Yeah. So let you feel. So actually, in your real world applications, when you implement many business features, it's very likely you need to do a lot of SQL operations. Yeah. Here, so let you do some hands-on related to this part. Yeah. All right. Yeah. So here, for the remaining of the time, let me set in this way. The first line, 4 weeks. Yeah, the first line, 4 weeks. Yeah. So if you can, after I post, just just in a few days, after I post it, I give you 4 weeks, and if you can complete it within the 4-week line, you can earn extra credit. Extra credit. Okay. Yeah. Yeah. At least 1%. Okay. Overall. All right. Overall. At least. Yeah. Why I say at least, but because I'm giving you 1.5. Okay. Yeah. In order to, because later, because for some other students who cannot make by this line, so I may give some extension. Yeah. Yeah. And for those who cannot complete, so you have about 6 weeks to complete. Yeah, 6 weeks. The second line. The 4 weeks, the first line. Okay. First line for extra credit. If not, you have the second line. Okay. All right. Then I talk about requirements. The university database, there are 5 tables. These 5 tables: course, grade, _report, my section. Oh, yeah, here. Remember, I changed the name. Actually, the original name is section. We know section is a keyword, all right? Yeah. So here I changed to my section. Yeah. Yeah. Actually, we know we can avoid it. Remember, we can avoid it. Yeah. Here, for that reason, yeah. So here, because section is a SQL, MySQL keyword. Yeah. Just let you know. Prerequisite and a student. So these 5 tables. Yeah. Okay. All right. Then the first feature, enter data. All right. First, we need to display the data from all these 5 tables. So each table, you have a hyperlink. Yeah. Like that. Yeah. When you click it, you access that table. You display all the rows of that table. Yeah. Actually, this part, I will give you the code. This part, so when you start, yeah, so this simple interface, yeah, I will post starting to get you started. Yeah, so, and I will explain my code. Yeah. All right, to help you get started. Then you need to add new features on top of that. Yeah. And after you get my code, you can modify the interface if you like, although it's not required. Yeah. Because some students, so they like to do some more work to make their interface look very good. Yeah. So last semester, a few students did that way. Yeah, it's okay. Yeah. So I encourage you, but because usually you need to spend quite some time. If some students willing to do that, so that's a good thing. Okay. Yeah. My sample code, I just do the minimum on interface. Okay. I do not have the fancy interface. Just what you see here. Just list the data directly. Okay. Then after that, you need to add this data input, one row at the bottom of each table. Because for each table, you need to enter new data. Okay, yeah. And this add button. All right. After data entered, so the user click the add button, that new row is added. Okay, that new row is added. Yeah. Although you may need to do some data validation here, basic. Yeah, here I do not require, advanced validation, but you may need to do some basic data validation. What kind of data validation? Yeah, first, non-empty. Think about that. Okay, non-empty. Yeah, because if user does not enter any data and click add, you need to display some error message, right? Empty data. All right, so that's one. And another basic data validation, think about, if a user enter a new role, you need to fill in all the fields, right? But think about if one of the fields is the primary key, think about primary key, but user enter primary key already exists. Think about if that primary key already exists, do you not allow it to be entered? You cannot. We know primary key must be unique, right? You cannot duplicate a row or a new row with the same primary key. Okay, yeah. That kind of validation, you also need to consider basic validation, primary key. Primary key violation, you need to check if there is a primary key violation. All right, yeah, basic data validation. Yeah. If more than that, I do not require it. Okay, yeah, more than that, I do not require it. Okay, yeah. All right, yeah. So here, primary key violation. Okay, violation. Okay, check. Okay, yeah. Then switch table, because we have 5 tables. you need to do the same feature on all 5 tables. Yeah. Then when you switch to a different table, then do the same thing, but I like you to do it in an efficient way. Okay, yeah. All right, so do data entry for all 5 tables in an efficient way. Yeah, so what's that efficient way? That means you do not need to write the similar code 5 times. Okay, we have 5 tables. You just copy and do modification, basically the same code 5 times. That's not efficient, although you can do that. That works. But I like you to write one-time general code covering all 5 tables. Okay, yeah. That part in my sample code, I'll give you that part. In my sample code, I list all 5 tables, but I do not copy the same code 5 times. I just copy, use one general time, one way covering all 5 tables. Because we can retrieve the table names. When we switch to different table names, we display data in different tables. In that way, write that code, table display code only once, covering 5 tables. You also do that. For data entry part, you also do in that way. Okay, yeah. Actually, for all the features, do in that way. Okay, yeah. Yeah. Try to do as efficient as possible. Yeah. Okay, all right, yeah. So that's another one, yeah. Then editing rows. Yeah. Later, we need to modify any row in the table. Yeah, here, for each row, we associate with an edit button. All right? So when you click edit button, you need to retrieve the data for that row and display in the bottom row in the here, like this. Yeah. Or, yeah, not in the bottom. Yeah, just right here. Okay, right in the original location of that row where you click the button. Okay, yeah, just display. Yeah, because you want to provide convenience for your users. Yeah, that bottom part is for new data input. Okay, bottom row for input. For editing, same location of the selected row, and the button is changed to update. Yeah, because you select this row, and the user can change the value of any field. Then click update button, the data is changed. Yeah. So you practice the update feature, insert feature editing, data insertion feature, update feature. Okay, deletion also, yeah. So you have deletion. Yeah, you can also do that. All right, yeah. And here another thing is I like to talk about technical difficulty. So there is some important technical difficulty here. So what's that? Among 5 tables, three of them have primary keys. But 2 of them do not have primary keys. Then you have the problem. Think about those 2 tables without primary key. How do you retrieve the data, right? The primary key, you can specify, where the primary key, equals. Yeah, so you can retrieve the data based on the primary key value. But for those 2 tables without primary key, how do you retrieve data? How do you update data? All right, think about that technical difficulty. Yeah, here, here, then let me give you a simple solution here. Yeah. Simple solution. Okay, yeah. Use the values of that row. Although not convenient, yeah, but of that row, that, values, several values. Those values just enough to identify different rows. Use values. Different rows have different values. Think about if there are 2 rows with identical row values, then we cannot separate, right? Yeah. Fortunately, for this example, we don't have such problem. Yeah, that's the good thing for this project. For this project, we do not have the situation there are 2 identical rows. So we can separate in this way. Yeah. Otherwise, how can you separate? Okay, for those 2 rows, yeah, without. Yeah. Right. Yeah. For example, yeah. So yeah, as I remember 2, yeah. Grade report, prerequisite, yeah. 2 rows, no primary key. Okay, yeah. 2 tables here. All right. Next, yeah. So this one a little harder. Generating a report for transcript. Actually, not too much harder, but you need to make some effort. Little, make some effort here. Transcript. What kind of transcript? Report. Yeah. Based on the picture from our textbook. So I took the picture from our textbook. Yeah. Then this is the screenshot. Yeah. Cut. The format like this. Okay. The format is like this. So for each student, so you list the grades for all the courses taken by the student. Yeah. So then, for all students. Yeah. The format also in this format. Yeah, but you need to generate, because you need to write a program to generate the code, display this table with this structure. Yeah. So here, you need to use, HTML. Yeah. Although not HTML, yeah, basic features, yeah. So, structure like this row span, right? Yeah. How to do the row span? Yeah. Here we do not have column span. Yeah. The good thing is only row span, right? Yeah. For each student row span. The number of rows, yeah, you need to count the number of rows, right? Yeah. Yeah. So you can use a SQL operation, yeah, how many rows, yeah, then how to set a row span, yeah, that part. Yeah. The reason I feel it could be a little hard for you, yeah, because last semester many students couldn't do it, based on what I saw last semester, right? Yeah. So, yeah. Although, so I can explain the idea, details, how to do it. Okay, yeah. But I hope you make it. Okay, so based on the, just the basic HTML features. So you can make it work. All right, yeah. All right. And yeah, so that's pretty much all the features. Yeah, but I didn't put here, but actually I would like to add another small feature. So very small feature, but ask you to practice some interesting technology. Yeah. So what's that? Under each table, I like you to add one button. Okay. Yeah. Add one button, like, get max button. All right, get a max button. So what's that? Yeah. So you have a display field here. All right. After you click the get max button, you display the maximum value of the first column of each table. Just this maximum value display right here. Yeah. That simple feature, I want you to practice a technology called Ajax. Simple, Ajax. We know this technology, very simple but very useful. Okay, I will talk about that. I will explain, the Ajax feature. Then you just practice. You click this button, then you display value using Ajax to do it. Okay, so that simple feature. Yeah, so here you can see, although we do not have much time, but I try to use this limited time to give you a chance to practice several useful features. Just let you experience something useful you may encounter in the real world applications. Okay, so that's the basic idea. Yeah. All right, so here I describe just give you general basic understanding, yeah, but I will post the detailed description, as HTML document. Okay, all these things, I write clearly in details. So then you just follow the instructions so you can start. Yeah, and for my part, I will show you some related features I feel. So you may need help. Yeah. So I use small examples to show you how to do different features. Yeah. All right. Yeah. So that's the project description. Okay. Yeah. All right. Yeah. So I will post, by Wednesday, right? By Wednesday. So I post this project first. After that, then I post quiz number 4. Yeah. Quiz number 4, because I can leave the, the whole spring break, yeah, for you. Yeah. After, yeah. All right. Yeah. All right. Then, part C, complex queries. C.2, nested queries. Right. In this part, we need to work on much harder, yeah, not too much harder, but much harder than the basic query operations. Yeah. All right. Here, one special type of queries called nested queries. We have 2 levels, outer query level and inner query level. All right, so first, let's look at the structure, the relationship. Yeah. Outer query, a select from where block. Yeah. So outer query, so we set a basic structure. Yeah. Just a select from where block, that basic structure. Okay, yeah. But then inner part. All right. Inner query, a query within the where clause. Inside the where clause, you may have another query. Okay, not just the simple condition we have before. Yeah. You may have another select statement. Think about that in the where clause. Another level. Yeah. That kind of, yeah. All right. Yeah. Oh. Oh, yeah. So I listed a few cases. This is the last one. Yeah. More cases. Yeah. Yeah. Other than this basic case, we have more cases. Yeah. All right. Inner query can appear in different places. First, where clause, the first case, the where clause. Okay. For example, where clause, we know usually in where clause, we specify select condition, right? Select condition. Yeah. Yeah. Here, we just talk about select condition, not join condition. Join condition, we do not use inner query, join condition. Yeah. But select condition, we can use inner query. Yeah. Think about, for the select condition, usually we describe condition, but in the condition, can you count the number of rows of the table? Yeah. Can you? Yeah. So here, example. Yeah. Select count function. Remember, we have a count function. We can count number of rows. Okay. Yeah. From some table. All right. So count function. It should return a number, right? Can we set the condition equals, for example, 3? Yeah. So you have another select statement, but we apply aggregate function. Then when we form our select condition, we use the aggregate function value. So that's the inner function, right? Inner query, right? Yeah. So you can do a lot of things like this. Okay. Yeah. For example, in our company database, yeah, think about the question, list those employees who have at least 2 children. How about that? This question. List the names of those employees who have at least 2 children. You need to count the number of children for each employee, right? At least 2, greater or equal to 2. So you apply the count function for each employee. So you get some number. Yeah. That number greater or equal to 2. Yeah. So this kind of queries very common, right? Yeah. Yeah. Where clause. The from clause. From clause, usually we are expected to put table content, right? Yeah, from clause. From. The from part. Usually following this keyword, we expect to have a list of tables, right? Tables, usually we put a list of table names, right? Okay, all right. Think about, is it possible we put a query result as a table? Yeah, think about that. Yeah. Select query. So here we use select query result as a table. How about that? It is also a table. Yeah. So we have the table content, but we do not have the name. Because the reason we do not have a name, we generated data. So the data is not from the original table, it's derived the data. Here we use derived data. And we do not have name for it. Although you can use alias, yeah, without name, but you can use alias, use an alias. Okay, yeah. Because later you may need to refer to this table. You need a name for it. You just use alias to refer to this table. Okay, yeah. So in the from clause, you can put a inner query there. So you can see many cases that could be pretty complicated. Yeah. Okay. All right. The select clause. Select. Yeah. So it's possible the select part, you may have another inner query. Select. Okay. All right. Yeah. Or other SQL clauses as needed. Yeah. Because you may have other SQL clause. Yeah. When you specify different conditions, you may have other keywords for different clauses. Yeah, 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 yeah. I hope the next time I give you some examples. So let you see some different types of examples before you can work on our query questions for the second homework assignment. Yeah, let me give you plenty of examples. All right, yeah. Comparison in operator. This operator also very useful in SQL queries, very convenient. Yeah. And it's very easy to use. So based on intuition, very easy to use, but very powerful. Okay, yeah. So definitely we need to use this operator quite often. Yeah. Description. The comparison operator in compares a value v with a set or multi-set of values, capital V, and evaluates to true if V is one of the element in capital V. Yeah. In math, we can use this understanding. Yeah. Because in math, for the set theory, yeah, this in just if V belongs to capital V, little v belongs to capital V, yeah, then it's true. That's simple. The simple meaning like that. Yeah. Here, we want to use this operator. All right. Difference. Here, there is a small variation, yeah, between equal and in operator. Equal, yeah, for the in case, yeah, think about V, capital V only contains one element case. Then sometimes some users, they use the equal operator. Okay, yeah, yeah. So for this special case, yeah, sometimes some users use that equal operator. Yeah. All right. If a nested query returns a single attribute and a single tuple, yeah, so both conditions should be true. First, it should be a single attribute. Second, a single tuple. Then the query result will be a single scalar value. In such cases, it is permissible to use equal sign instead of in for the comparison operator. Yeah, yeah. So for this special situation, in and equal, they have the same meaning. Same meaning, yeah. Although most of us probably we just like to use the in operator. Yeah. Why we separate? Sometimes in, sometimes equal. Yeah. Here, I describe this special case because you may see such queries. When you see such queries, you understand the meaning. Yeah. Just a special case for the in operator. Okay, yeah. So you can understand it easily. Yeah. Although you may like to use in that way, or some of you may not like to use in that way, but other people, they may use in this way. Okay, yeah. All right. Let us look at this old example. We did this example before, yeah. But here, let us use this new way to write it. Okay, yeah. Make a list of all project numbers for projects. Oh, yeah, because remember, involve an employee whose last name is Smith, either as a worker or as a manager of the department that controls the project. Two different cases. Think about when we learn that set union operation, we used this example before, union operation. Okay, yeah. All right, so here we use a different way. So you can see many queries, we have different ways to write the same task. Do the same task, you have different ways. You just find some way that you feel relatively easier for you. All right, so here, yeah, select distinct P number, project number, yeah, from project. Only one table, project. Yeah. Then inner query. Yeah. P number in, you know, in operator. After in operator, another select query. Look at that. Another select query. Select from P number project department employee because here you want to describe the department manager whose name is Smith. So you need to use the department table. Okay, yeah. So the table join and yeah, because you need to join twice, two join conditions for three tables. Yeah. And here the manager, yeah, so you only want to look at the manager information, the manager's last name Smith. Yeah. Okay. So those project numbers, P number should appear in this list. Yeah. Project number controlled by department whose manager has the name Smith. Yeah. Look at first part of this query. Okay. Second part of the query, employee. Yeah. All right. Yeah. The project involved by this employee with last name Smith. This time you use the works on table. Yeah. Join last name Smith or operator. Yeah. Okay. Yeah. Boolean. Yeah. Here. Because either the first Boolean statement. So here, this is the first Boolean statement. First Boolean expression. All right. Yeah. And this is the second Boolean expression. Okay. Yeah. So either the first one is true or the second one is true. So or. Okay. Here you can see. Yeah. So you avoid that union operation, right? Yeah. So in this one, we didn't use the union operation, set union operation. So we just use the basic Boolean operation. So we can get around it. Okay. Yeah. Yeah. All right. Yeah. So this example. And here you can see we use the in operator in this way. So very convenient. So it's a powerful way to write queries. Okay. Yeah. All right. Yeah, but here one thing I like to point out. Here we use distinct keyword. This, yeah, probably. Yeah, probably. Yeah, because first we know the P number is the primary key of project table, P number. Okay, yeah. And we know the project number in the project table must be unique, right? Yeah. So it looks like we may not need that distinct, but we have this all when you combine two tables. So here is just combine two tables. Yeah. P number, the project number in this one, or in that one. Yeah. Each. Yeah. Actually, yeah. Even we use this all operator, each project number still we only consider once, right? Now think about from this project, because from project only one table. Okay, one table. Then in this table, we go through all the P number. All the P numbers. Okay, yeah. But each one only once. That means we do not have the duplicate project numbers, right? It's a primary key. So we go through all the values in this table through the primary key values. No duplicates. Yeah. So that means distinct keyword is not necessary. Yeah. But why I mention it, some people may argue, although it's not necessary, but the result is the same. Yeah. You put keyword distinct or without keyword distinct, you get the same result. That's correct. But the performance will be different, right? When you use the keyword, the performance is slower. Although you get the same result, but you can do faster without distinct. Okay? So with distinct, slower. Think about it. Because we need to apply special operations in order to do the distinct operation. For example, sorting. Sorting may be needed. If you do sorting much slower, right? Yeah. Without distinct, you do not need to do sorting. Yeah, it will be much faster. Yeah. Think about that. Okay. So if you can avoid using distinct keyword, you should do it to make your query much faster. Okay. Yeah. So that's the comments for this example. Yeah. All right. Yeah. C.3, more understanding on table join. Yeah. I mentioned this question before, but here, let us learn more information. Yeah. Join the tables. We did that before. Right? Join the tables. Yeah. All right. So here, implicit table join. What we did before, we used the implicit table. So here, we like to learn explicit table join. Implicit, explicit. So we want to see the main difference between these two types of table join. Implicit, without using the keyword join. Our current version, we do not use the join keyword. We just use table name 1, comma, table name 2, comma, and so on. Yeah. So that's our current way. That's the implicit table join. Then in our where clause, we mix together all the select join conditions, select and join, both. Yeah. Both select and the join conditions in the where clause. Yeah. So when you use the implicit way, then you need to do this mixed way. Both select join conditions in the where clause. Okay, yeah, yeah. All right. For comparison, let's look at explicit table join. For the explicit table join, you separate these two different types of conditions, table join conditions and select conditions. Yeah. First, this time you need to use the keyword join, explicit join. Okay, all right. Separate the select and the join conditions. Yeah. In the from clause, right? The join, you use the join in the from clause. Yeah. Move the join condition to the from clause. When you join tables, you specify join conditions in the from clause. In that way, so you can see clearly the joined table structures clearly. Okay, yeah, put together the tables and with join conditions. So let you see the whole join table structure immediately, right there in the from clause. Okay, yeah. In the from clause, specify a table resulting from a join operation. Yeah. Then in the where clause, you only specify select conditions. Why do in this way? Yeah, because usually for relatively complex queries, many people like this way to make the understanding, the comprehension better. First, you do not want to put everything in where clause to make it, very hard to understand. Okay, yeah. So you take away the join conditions. The join condition, that part relatively easier. Yeah. All right. So then separate it. So they only specify the select conditions there. Okay. So then, join. Yeah. All right. Yeah. So, but usually for relatively easy questions, so then, many people like to use the implicit table join. But for relatively harder queries, so then for better readability, for better understanding, so many users, they like to use the explicit join way to write the queries. Yeah. So let's look at one example using the join the table explicit way here. Yeah. Implicit way, we are familiar with the implicit way. Yeah. So this one's still old example. Yeah. Retrieve the name and address of every employee who works for the research department. Yeah. Our old way, we use implicit table join. Yeah. Here, we like to use explicit table join. Yeah. Analysis here. Tables to be joined, employee table and department table, two tables. Yeah. The join condition, how to join these two tables? E dot dno equals D dot D number. Okay, yeah. The select condition research, yeah, the department name, D name equals that research. All right. So the join the table explicit way in the from clause, we write this way. Yeah. Employee as E, alias first, then join keyword. Join department as the alias on, after that, on keyword. Because you need to provide join condition after on keyword. Then your join condition. So you get a whole join the table all together in this from clause. In this way, you want to describe the structure of your join table clearly in this way before you apply the select conditions. That's simple logic, okay? For better understanding. Yeah. All right. Yeah, so then let's put everything together so we get the statement like this. Yeah. All right, so here, one thing, yeah, because we restructure this query statement, this time we have an inner, yeah, so here, yeah, we can treat it as, yeah, I mean, table join, yeah, we may not, yeah, here, we may not call it inner query, yeah, because inner query, it should be a complete query, right? Yeah, select statement. It should be a complete select statement. Then we can call inner query. Yeah, but here, this is not a complete select statement. Yeah, it's just explicit table join. Yeah. All right, so we describe that. The whole thing as one table, but this table, because there is no name for it, it's hard to refer this table if we want to use it later. Yeah. So for that reason, we assign an alias to it, E2 alias. Yeah. Then after that, we can refer E2.FName, E2.LName, E2.address. Yeah. Okay. Yeah. All right. Because otherwise, if you do not use alias, when you say FName, do you mean employee's FName or the E2's FName, right? You get confused. The derived table, the joined table has that FName. The original employee table also has that FName, right? Yeah. So where then select condition. Yeah. All right. Okay. Yeah. Then, all right, I just have 2 minutes. So because this slide is very short. So let me complete it. Attributes of a joined table. Attributes. I forgot to turn off. Just garbage call. All right. Attributes of a joined table. Yeah. Here, the basic rules, just based on our intuition. How do we form all the attributes of a joined table? As before, here we assume we have two tables, two relations, R and S, and we join them, R and S. Yeah. All right. But we need to list all the attributes in these two tables. Yeah. All right. All the attributes of the first table, yeah, you list them in the natural original order first. After that, then you list all attributes of the second table, preserving the original order. Back to back. Okay? Yeah. That's the natural order. Yeah. Use aliases of tables to qualify them. Yes. Because this table has no name. Yeah. So you need to, you need to use the alias to qualify them. Yeah. And actually, if you do not use alias, the DBMS will complain. In this situation, if you do not use alias, the DBMS would complain. Okay? Yeah. Yeah. So something is wrong, Yeah. Okay. Yeah. All right. So that's this